Okay. Good evening, everyone. The topic for our presentation today is missile and launch vehicle guidance systems. Um, as everybody know, guidance systems kind of helps the missile to decide the direction in which the missile should move. Usually, the ballistic missiles simply follow an arcing trajectory to their target, whereas the guided missiles uh, are the one which track and hunt their targets. Usually, the guided missile systems were first developed by the Germans during the World War II, but they weren't that much precise. So, the quest for precision and accuracy enabled development of new advanced systems that can be armed with a range of warheads and accurately hit targets. So the modern systems can even carry nuclear warheads to target across the globe. So usually all the guided missiles are made up of several key components, which includes engine, warhead, flight control system, and a guidance system. Out of these four, our main concern is towards the guidance system, which locates the target and guides the missile towards it. The guidance system is it like allows the vehicle to reach its destination by combining the target location information with the navigation information. Now, when it comes to the missile guidance, there are basically several methods that come into use. The first one is the command guidance system. This kind of guidance system usually track the missiles from the launch site and transmit the commands by radio, radar, or the laser impulses. Today, a radar unit in the missile is often used to track the target and transmit bearing and velocity information to command guidance system, where control system compute the optimal trajectory and send commands back to the missile. Uh, Using radar, radio, or infrared sensors located on the launchers. And also, the errors can be computed by finding instantaneous positions of missile and target. Now, if we come to the advantages, we said, it needs little guidance equipment on board of the missile, but this gives the disadvantage like it can't be used against situations of multiple targets. So the next one, guidance system is the homing guidance system, which are generally used for short range missiles. Also, these missiles receive signal which are either reflected or emanated from the target. There are basically three types of homing guidance systems. The first one is active homing. The active homing tracks the target with a radar transceiver. That means there's the transmitter and receiver that is contained in the missile itself. So, since these systems don't require signals to be sent from the launcher side, they make it more difficult for the enemy or the target to locate their launch platform or the aircraft that fired that missile. Um, the next one is the semi-active homing. It is kind of which has a separate targeting radar on an aircraft that eliminates the target guiding the missile towards it. The source for target illumination is located in the launcher, while the missile only has the receiver in it. So, since the launch aircraft has to keep moving towards the target, to maintain the radar and guidance log, there are potential that the aircraft will come within the range of the enemy. So this is kind of a disadvantage for semi-active homing. The third type of homing guidance system is the passive homing. Passive homing. For the passive, it don't need energy or receive commands from an external source. Like, it only has a receiver. It doesn't need a transmitter from neither from a launch vehicle. It They only took an emission coming from the target itself, and missiles like which uses infrared homing. Like if the target is emanating infrared signals, they are usually called heat-seeking missiles. And these passive homing can be used with other modes of guidance system to work much more efficiently. The next type is the beam rider guidance system, which illuminates the target by radiation of beam of energy from a radar antenna pointed at the target. Usually, the equipments in the missile measures the displacement of the missile from the center of radar beam. Although it is simple, less complex, and of a lower cost, but it causes the limitations of trajectory requirement during the terminal phases, and the precision decreases because of that. And the final type of guidance system that comes into play is the initial guidance system. It is a system that continuously monitors the position, velocity, and acceleration of a vehicle. The missiles are programmed with predetermined flight paths. They use gyroscopic platforms and GPS to continuously determine the positions of the missile in space. The guidance computers then combine the position information with velocity and direction information to generate commands that maintain the proper course. These systems are advantageous because they don't include electronic emissions from a missile or a launch platform, which could be picked up by the enemy. Uh, the feasibility of multiple guidance mode is currently being examined, like homing modes being considered in addition to semi-active, including active and infrared and wideband home on jam. Some of the more attractive multi-mode combination include semi-active thermal supplemented by either active or infrared, active terminal supplemented by infrared, and these plus wideband home on jam. There are currently like several programs that have been initiated to demonstrate the technology required for alternate or supplemental guidance modes. Like for example, um, the development of high power active transmitter, multi-band antenna systems, and infrared domes for high speed flight. So the physical integration of multiple sensors into guidance package and definition of multi-mode guidance uh, control logic are also need to be the areas where more research is to be done. So thank you. This is all.